Hi, my name is Zenka Caro. I'm founder of LightNet, and my passion and purpose is to make the impossible possible. I'm sitting here today with one of my son's friends from Cordoba, Argentina. Yes, these boys are 10 and 11 years old, and they talk about their passions. I remember interviewing my son for the Purpose Lab, and what he said was, and that is true. That is what we've discovered. It's an inside job, which is incredibly scary and exciting and interesting at the same time. He also said that your purpose is something that brings you joy, brings you happiness. And that is also true. That's a commonality we found in all of these interviews. And this one is no exception. Now, we are sitting here in Cordoba, Argentina with Jano Quantum. He has done a TEDx talk and he's fascinated by quantum physics and music. He's sitting down with Mateo Arias, who is a student at the Music Children's Special School in downtown Cordoba, and he's interested in basketball, music, filmmaking, and more. My favorite part of the interview was where they talked about black holes. Check it out. This is an incredibly charming video. And we also have this in Spanish if you want to hear how the children sound in their native tongue.
I'm passionate about, honestly, a lot of things. For example, I'm very passionate about quantum physics, which is basically the science that talks about the smallest things at the atomic and subatomic levels. I'm also very passionate about music. For example, I can play the electric guitar, I can play the trombone. The trombone, honestly, I'm just learning to play. It's been about a month. And then, well, the clarinet, which I've been playing for 2.5 years approximately. 2 years, really.
My passion is the art of cinema. Also, being a YouTuber interests me a lot because besides video games, I really enjoy making anything related to recording. Making videos, shorts, editing, uploading to YouTube.
A film is something that I really enjoy. I also enjoy music, learning beautiful melodies. I also like art, where I can let my imagination out. I can even put whatever comes to mind on paper. And this is something that I can't do on a screen or anything.
When I grow up, I would like to work at CERN, which is where the LHC is the largest particle accelerator in the world. And I would also like to play the trombone. It's been a month now since I started. The clarinet, which I've been playing for about 2 years. And also, I already know how to play the electric guitar. I wouldn't like to dedicate myself to that. But honestly, I would love to also play in an orchestra.
There's a lot of mathematics in music. For example, waves and harmonics. For example, take the resonance wave of a particular object. A resonance wave is, very briefly, is a vibration. It is a vibration that a certain object produces. Ito takes advantage of the spaceness it had to vibrate, and that is what makes it vibrate. Say, for example, sometimes when you're playing, it happens to me, I play the clarinet and then things in my room start to vibrate. For example, my flamenco starts vibrating like that because of the waves of resonance.
I love basketball because it's a very beautiful sport, and when I do it, I can practice my jumps. It's something that I like because I like to be free, running, and this is what I love.
A curious fact is that I'm making a periodic table, a kind of periodic table, but it has instruments. There are so many instruments in the world. For example, the BC, which is a wind instrument, the octave, the reed contrabass, the octobass. Yes, it's crazy how many instruments there are, considering all the tunings.
I have a saxophone in miniature that came with my elf figurine.
How nice. And in fact, the saxophone, there are more than 10 types of saxophones. Imagine the number of types. For example, there are string. There are easily more than 50 types of string instruments that are the violin, for example, the spiked viola, things like that. So it's impressive, for example. And the ones used are just 4. But there are easily 20 types of saxophones, and each one has to fit perfectly on the chart. Each one, and that's the crazy part. It's crazy, but it's a big project, but I really like it. So for me, music, I love it. Imagine there are more than, for example, there are gigantic families of instruments. For example, the oboe family has more than 40 types of oboes.
And speaking of the saxophone, here, Alf comes with a saxophone figure.
That is an alto sax. Yes, an alto sax. There is a baritone sax. It's a sax that is twice as long as that one. In real life, a big thing like that, then I don't know, the tenor sax, the alto sax, the sax, and the soprano sax. Those are the main ones because there's the sopranino and the sopranissimo. The soprano is a long tube, it's like a clarinet. But the truth is, I am passionate about those two things. Music, which I am extremely passionate about, and also quantum physics. When one feels signs of having found something they really like, something they are passionate about, something that makes them feel like they are in another universe, something they enjoy talking about. For example, quantum physics, the problem is that it is very difficult to find someone to talk to. It's a subject which is like super eccentric.
But when you found me, I became very interested in quantum physics.
What I like about quantum physics, because it is a complex topic, it is complex. It is something that's difficult to understand. For example, if I tell you something is in two places at the same time, it is, but it is, it's on one side and it's on the other, it's real, it's in two. We're not imagining it's in two places at the same time. It is. Things that are in two places at the same time, or that travel at two different speeds, or that orbit at two different speeds, two different trajectories, two different positions, rules of quantum physics like entanglement, then things like Heisenberg's uncertainty principle and chemistry. I like chemistry too. It's related because atoms are small things. And atoms are made up, as everyone knows, of protons, neutrons, and electrons. Now, what not everyone knows is that inside protons and neutrons there are quarks. Quarks are particles which are fermions. They are part of the spin family, which is spin.
Well, in the quarks, you know those typical ones that always have like a B, the A, B, C, all right? Well, they are like that. You could imagine a color, blue, green, and red.
Perfect. That is the color composition of the little strings in quantum chromodynamics. But before, you will continue later because you are explaining it very well. What happens is that they are fermions because they have a spin that is a spin. Let's say it's a spin that is not an integer. Integers are the spins of bosons, which are 1 or 2, for example, or 0.
Instead, these have a half spin. Just to give you an idea, a half spin means, can you imagine that spin is an intrinsic property, an elemental property of particles? And in this case, the spin is a spin like that of the family of electrons, the family of leptons.
In each family, there are 6 types of these particles. It turns out that it has a spin that is a fraction, isn't it? It's 1/2.
It is not whole. And as the Mateo rightly said, inside protons and neutrons, there are 3
quarks. In protons, there are 2 up quarks and 1 down, and in neutrons, there are 2 down quarks and 1 up. The names are in English, and each one has a color.
Red, blue, and green. And to unite, these particles use the so-called strong nuclear force. The strong nuclear force is a force that interacts with quarks and is what keeps them together in protons and neutrons, respectively.
And it is that they basically function by exchanging, they keep exchanging them, and this is what causes them to stay together. This is how quantum physics explains forces. And there is a particle called a boson, and the boson is what other particles exchange, for example, 2 photons.
For example, 2 magnets exchange photons, the light-carrying particles, which is what we see. Our brain detects photons and translates them as light.
And also, they are particles of electromagnetism. That's what's important now. And it's that when magnets are exchanging electromagnetism photons, what happens is that they are it's like 2 skaters passing snowballs to each other. That would happen in a case of, for example, 2 negative poles or 2 positive poles. By passing the snowballs, they would start moving apart because, of course, so what happens? Yes, that's how it would work. That's how quantum physics explains forces. And for example, the opposite would happen with a negative charge and a positive one, right? What would happen is that they would start getting closer by exchanging particles.
What a long and extensive, exciting, and impressive topic. Well, if you have the power of a wormhole, you could.
Actually, wormholes would be quite difficult to pass through. None have been detected, and if they were discovered, it is most likely that they would be impassable because the distortion, the gravitational force of a wormhole would be so powerful that it would end up stretching and crushing you as if it were a black hole.
So what has been developed is not exactly teleportation, but rather quantum teleportation. That's what's important. Because it's not exactly teleportation, what is done is
something is grabbed. It is destroyed and copied exactly the same in another place. But it is not the same object, it is an identical one, but one is destroyed. So imagine they would have to kill you to create a copy of you somewhere else. Besides, that works on very tiny scales, very small scales, proton scales. And speaking about the topic of space, if you know through the black hole,
If you want to observe a close-up black hole, it is impossible because the black hole has a force field.
You will see that sometimes people draw it with stripes. Well, it really is just a black hole, but they make the stripes. For me, it is a theory. I don't know. To see the force field it has. You are talking about the rings, right? If those rings do exist?
But there is a part that if you get close, an object, no matter it is, something could observe you, bring you in, and eat you.
And it turns out that the issue with black holes, what happens is that it works like this. They have a disk around them, then there is the matter that it attracts. They have a disk that spins around it, and little by little it gets swallowed. And it turns out that what says the mate?
And it turns out that what Mateo says is basically the point is an energy point. To escape from, you need a certain velocity. For example, to escape from Earth, with this speed you cannot escape because it will attract you again. Therefore, you have to have a certain speed, the so-called escape velocity, to be able to get out.
The problem is that the escape velocity of a body changes depending on how close you are to its core, to its surface, let's say. The black hole could be escaped. The problem is that there is a point. A little beyond the shadow of the black hole, which is what would happen, called the event horizon of the point of no return. At the point of no return, not even at the speed of light, it could escape because you need a higher escape velocity than light, and the speed of light cannot be surpassed. Well, you can cross it, but not in real life, but with power, but with imagination. Yes, that's true. In fact, it's known that there's a point in which a limit where it is not known what would happen, the laws of physics quietly break. Inside there could be a boundary. A monkey with symbols. Inside there could be a unicorn next to a hippogriff that's on top of an elephant holding an oboe. I mean, anything could really happen inside. There could be a unicorn in there. It's unknown. The physical laws are not respected inside that point. It's a point deep inside the black hole. Which point? Oh, the black hole.
And it turns out that the densest part of the black hole is distorted space-time. The singularity, a point where space-time would be, let's say it would have a mass there,
infinite, let's say. But the horizons, the problem is that this is very strange because it is very ambiguous. It depends on the type of black hole where it is. Sometimes directly this singularity is not in space, it is in time. Oh, it depends, and it's because the black holes of our kind are Kerr black holes. And well, it's a whole type of... The topic of wormholes is incredible. If I had a magic wand, the first thing I'd do is get a bunch of instruments and have a super house just for the instruments. It would be an instrument museum, and then I think that, and after I would buy books, study a lot. I would have some kind of laboratory, somewhere to do research. And then I think that, and after I would buy books and study a lot, I would have some kind of laboratory, somewhere to do research.
Would like to have this too. To have all the types of saxophones, then have a pet Alf.
Don't worry, I would also make my little dog immortal, so she would never die. Lavina is my dog's name.
I would make all the animals in the world immortal, because it also makes me very sad.
Sadness, remembering when they had trapped in a zoo that I loved. It made me very sad when I saw that lion that was literally looking for a way out, crying. Its eyes were always teary because it was trapped there, and it made me very sad when I saw it there locked up. His eyes were always watery because he was trapped there, and it made me really sad when I saw him there locked up. It occurred to me too.
When they took it out, that was my wish for my birthday, that they would set them free.
Super happy. Finally, here in Argentina, they released the animals in the zoo to return them to their families. Because I think that when they banned zoos,
They thought of something like, how would you feel if they caught you? They left you in a place
and they feed you noodles with flour, or something like that, and you didn't like noodles, and they separated you from your family, the ones you loved a lot.
And that is how those animals felt.
I like it. I would also like to have a collection of elements. I really like the elements. For example, I would love to have a tungsten cube. We did the math with my dad. How much do you think a cube of this size of tungsten weighs? For you, how much does it weigh? For me, a lot. A cube of 10 centimeters by 10 centimeters by 10 centimeters is 163 pounds. 163 pounds! A tiny cube like that, I love tungsten. Quantum physics have a lot of applications. For example, there are many applications that can improve, for example, the performance of video games and computers. Quantum physics and quantum computers are incredible. Quantum computers. I have to talk about this. A classical computer operates with bits. Do you know what a bit is? It's a number that can be either 0 or 1. And depending on the combination, it can represent letters, images, but the qubits in quantum computers are 0 and 1 at the same time. And when you say 1 at random, it's like, for example, the family of, for instance, particles. There's a theory called the... what is this theory called? The theory, yes, of supersymmetry. It says that each particle has a sort of twin, and that this twin only... They would have, if it's a fermion, it would be a boson, and a boson would have the superpartner fermions. And it's that the name, they always end with ino, gluino. All of them are super funny. Gluino, fotino, he, quark, hapino, things like that. And there, thank you for your curiosity. I also learn from your curiosity, and I love what you learn. Thanks for your curiosity. I also learn from your curiosity, and I love what I learn. It is like a world full of adventures with Jano. More or less, it is like being inside of Minecraft or Nintendo or any game. There is always an adventure. It seems like an adventure.
But instead of a real-life adventure, it is an adventure of knowledge.
Real life is an adventure of knowledge. Knowledge is real life for me, and knowledge for me is it's one of the things I value most in people, besides their loyalty. And there are people who maybe think, I can't talk to this person because surely they won't like what they might say. And this has happened with Jano. But when he saw me, and I found out that he knew so much, I knew that there are many trustworthy people who are very interested in the wisdom he knows. When he saw me, and I started asking him things, I found out he knew a ton. I wondered, what is he going to do with this gift? Oh, thank you very much, Mateo. I remember the day when on the bus they told me another kid is going to come named Mateo, and I was like, wow, no. I was so excited that we were going together.